Right then, let's do carbohydrates. So the last subchapter of organic and biological chemistry, sorry. There is not many points. There you go. Student intended learning to be covered, 5 of them. Firstly, given its structural formula, determine the molecular formula of an organic compound and whether or not it's a carbohydrate or not. So as long as you know the basic shape and requirement for carbohydrates, that's really done. Second one, write molecular formula for glucose and for disaccharides and polysaccharides based on glucose monomers. So you're only required to write molecular formula, not structural. Okay. Third one, identify the repeating unit and draw the structural formula of the monomer given the structural formula of a section of a polysaccharide derived from one monomer. Because if you're looking at bigger structure, it appears like polymer. So as long as you can identify the monomer unit, that's really that. Second, from the bottom, explain the ability of glucose to react as an aldehyde when in chain form, but not when in a ring form. You will see different forms of glucose later on. And finally, explain the difference in solubility in water of simple carbohydrates and polysaccharides in terms of the size of the molecule and the number of hydroxyl groups. Okay, so solubility is physical property. Okay, carbohydrates in general, they can have a chain or cyclic structure. Now, if you can open essentials, we probably looked at some of them before, but we'll revisit that again. So at page 293 to 294. So on page 293, you will start seeing the list of, firstly, monosaccharides. So monosaccharides, and there's a column for ring structure or chain structure. So some of them haven't got ring structure just because they haven't got enough carbon to make a ring. But from glucose or fructose, hang on. Yeah. What's the second one there? Ribose, okay. Ribulose and ribose. So those ones haven't got enough carbon to make a ring structure. And if you go on to page 294, you will see more familiar shapes. So pentagon or hexagon looking ones at the top. So glucose and fructose. Okay, there you go. So fructose and glucose. Something that we even talked about when we looked at making alcohol. Yeah, the practice we did. And down the bottom on the page, you will find carbohydrates with 2 rings attached to each other. So they all have rings. Because you see 2 rings, they are categorized as disaccharides, yeah? And if you look at the right-hand side, you see polysaccharides. Yeah? All right. What's the common thing between all the carbohydrates? Well, hopefully you can all identify the molecular formula. Molecular formula having CX and H2O with Y in front of after that. So basically what it's saying is that if you have got certain number of carbon, all right, you will have hydrogen, which is a double of number of oxygen. Yeah. So the second is hang on, C12, it's not glucose, the sucrose maybe? I think so. So C12H22O11, so there are 2 rings of carbon, and H12O11, that could be a smaller chunk of for which one it was. Anyway, that conforms the general formula of CxH2O and times by Y. C6H10O5 would probably be fructose, and glucose C6H12O6. So that needs to be the general formula. And yeah, for carbohydrate to be carbohydrate, it needs to have the general formula. Yeah. Secondly, they all need to have either ketone group, so CO double bond, or aldehyde. Okay, when it's in the especially in chain structure, and multiple hydroxyl groups, OH minuses. So any of the carbohydrates that you look at on those tables should have many OH groups. Okay. Now that's the reason why carbohydrates are also called as polyhydroxyaldehyde or polyhydroxy ketones. Polyhydroxy, so many hydroxyl groups, aldehyde, or polyhydroxy ketones. Okay, so that's a general formula and the general rules for molecules to be considered as carbohydrates. Got that? Yeah, there are really 2 things that you have to look for. So you need to be able to determine if a molecule is carbohydrate or not using, especially the rule number 2. Okay, carbohydrates, they are sugars and they're polymers. Empirical formula that we can talk about. What is empirical formula again, by the way? Do you remember the type of formula? So we talked about molecular formula, structural formula. Hope you're familiar with these 2 at least. What does empirical formula show you again? That would be skeletal structural formula. Right? Empirical formula means simplest ratio of all the atoms involved, types of atoms involved. Okay. So for example, if you had C6H12O6, that would be glucose, wouldn't it? Yep. C6H12O6. That's a molecular formula. What's the empirical formula for glucose then? CH2O. Good. CH2O. Because that's the simplest formula. Sorry, simplest ratio of all the atoms. Yeah. So that would be different if it was like C6H10O5. Yeah. Because you can't simplify any further than that, but glucose you could. Yeah. All right. And that's an empirical formula, a bit of revision into that too. There are 3 basic types of carbohydrates, and we already said monosaccharides, single unit, disaccharides, double unit, sucrose, for example, polysaccharides, many units, and you are seeing that in the table, those 3 tables before. What's the what's the example of monosaccharides? You can tell from the table, or something you know. Glucose is definitely monosaccharides. What's the other common one? Fructose. Yeah, something you can extract from fruits, yeah, or a lot of plants. All right, at least remember those 2. Polysaccharides, many unit sugars. So starch is one of them. And something that a lot of people are getting, more allergic to, gluten. Yeah, gluten is polysaccharides as well that you can make. Is there anyone here who has got a dietary requirement for gluten? No? Good, because we'll do kitchen practical probably in term 4, beginning of term 4, before you guys go in week 2. So you'll be making steak, so protein will be something that we're doing. I'll give you some rice, and then you check the starch content after chewing a bit. The enzyme in your saliva will break down all the starch into smaller parts, monomer units hopefully, so that you don't see any more starch after a while. And also glutinous rice cake. So from powder, you make bigger polymer, and you get mochi out of it. So yeah, that's something you'll be doing as kitchen prac. Okay. What is that in the middle? Condensation. I don't like the formatting. Monosaccharides, they can be joined together through condensation reactions. It forms disaccharides and polysaccharides. So something that I was talking about just then, if you start from powder starch, if you heat up, add water to it, they become gluggy stuff, bigger starch molecule. I mean, you are already starting from powder particles, so that's already in polymer. Yeah, but you can keep joining it and then make even bigger, longer chains. Okay. Gluten is the same. When you bite onto bread, and if you feel that that's chewy and nice instead of crunchy and crumbly, yeah, that means the bread has got gluten in it. So yeah, that's why it gives you chewy texture. How did that happen? Well, if it's bread, you start with flour. Yeah. If the flour had a bit of gluten in it, by adding water, heating up, chemical reaction occurs, and they join together. Yeah. So monosaccharides can be joined together with condensation reaction. Did I say add water? Water needs to be coming out, isn't it? If it's condensation. Now, if you look at any of the carbohydrates, so monosaccharides, for example, glucose or fructose, what's on the end of a molecule? Do you see OH groups or not hydroxyl, aldehyde groups? Yeah. There should be hydroxyl groups. So say one of the hydroxyl group has been lost, and hydrogen from another hydroxyl group has been lost. They will join up, losing water. If you're cooking bread, I guess that water will be just steam. Okay. And on the other hand, adding H2O. So I was actually talking about the wrong way around. Alright, adding H2O would break polysaccharides into disaccharides and further into monosaccharides. So that would be something that happens if you start chewing onto a piece of bread or piece of some rice. Alright, how would you write the polysaccharides to disaccharide equation? Well, if you look at next page, the general equation for it. Yep. No, that's a total equation. Polysaccharides. I think there was an equation somewhere saying that polysaccharides to disaccharide would look like I think I used C6H5O. So C6 H10O5. So any generic polysaccharide plus, I'm pretty sure it's half H2O, half the number of H2O. So there are so many numbers of monosaccharides attached to each other, and if you add half the number of water molecules, what would happen should be half the number of whatever that was there. And what should you get? What should it be? Disaccharides, so C12. So that will be polysaccharides to disaccharide. And if you start the next process of disaccharide to monosaccharide with that disaccharide.
Wait, didn't you say that would be half the number?
Yes.
I don't understand.
Okay. So this n, let's say that that was 1, 2, 3, 4, 5, and 6 joined together.
Yeah.
So if n was 6 lots of this,
Yeah.
and water will be added to here and there. That wouldn't still be right, would it? That doesn't look like half. That needs 3 bonds. Oh yeah, because the ending needs to be changed here as well. I reckon one of the ends need to be changed as well. Yeah, so when half the number of the molecule, the monomer part were there, then you would get so 3 disaccharides instead of 6 that was in there. That's why it's half the number of whatever that was here.
Wouldn't it be smaller? The C12, wouldn't it be like C3 or something like that? Why is it almost double?
Because this is now the whole molecule. There were 6 carbons in here, 6 carbons in there, still 6 there.
Yeah.
So in total you still have 12 carbon as one molecule. But because this this molecule need to be disaccharide, yeah. So
Okay.
yeah. Yeah. And if you have got that to start with,
that first one is bigger than the C12 unit because it even times everything by n inside that.
okay.
Yeah, it's just
Yeah.
confusing because it's like it's a smaller
Yeah.
in the brackets. It's a small molecule than the other one, but just because you times it by n.
Yeah. The end product you were looking at needed to be disaccharide. Yeah. That's why. How many of the disaccharide unit can you find? There should be half of whatever the unit, monomer unit there was. Yeah. And now if you start from disaccharide, which has got 6, how many monomer unit can you find? Well, if you add H2O, there should be 2 C6H 12O6. Yeah. So now you have 2 separate ring of monosaccharides. Yeah. So this is for polysaccharides to disaccharides, disaccharides to monosaccharides.
We need right states.
Hmm?
We need right states.
Yes, but no. It's a bit hard to tell. Glucose, unless you do cooking, you might not know that normal glucose is liquid, but the glucose that we use in lab is solid because water is taken out of it. Water is usually part of a complex in kitchen. That's why you get gooey, sticky stuff. So yeah, it's a bit hard to tell. Only equations that you are required to write states will be redox, ionic, and thermochemical. They're the only three. So you wouldn't get marked down even if you didn't write that. Okay. So now that we talked about adding water, hydration, and got down to monosaccharides, in this case we got glucose, C6H12O6. Any sample glucose, they can have either chain or cyclic structure, the ring structure. The rings are spontaneously converted to the chain and vice versa. An equilibrium between these two will be established in any case. So hope you can see that CO double bond here. So it's a high, can you see that that's aldehyde group here at the end? CHO here. So one of the bonds in this carbonyl group can grab the carbon here. That would make this oxygen within the ring here. Okay. Hence, that would leave CH2 and HO.
What is the oxygen doubling to?
Sorry?
Because it goes into a line.
The oxygen now has got two bonds, one into this carbon and this carbon.
Oh, is that the carbon?
Yes.
So it's not labeled.
Yeah.
Alright.
Alright. So just a mechanism, background knowledge though. You don't really need to know that. What you need to know is a lot of monosaccharides can exist in ring or chain shape. Okay? The chain structure, they contain an aldehyde group, as I pointed out. Meaning, if you have Tollens reagent, do you remember what we discussed about that? Tollens reagent? So when you have aldehyde, back in year 11, you guys weren't here, but back in year 11, when you made aldehyde, when you successfully created the aldehyde, you were able to get probably a streak of mirror in the test tube made with silver. Okay. If you have a lot of aldehyde and if you can oxidize it in ammonical silver nitrate solution, that's a reagent you use to make the mirror to prove the aldehyde is present. Okay. Because aldehyde is part of the chain structure of monosaccharide, the glucose that we are talking about, you can oxidize it. Okay. When sugar is being oxidized, what's being reduced should be silver. So silver should just come out as deposit. Okay, and it makes a mirror. So that's what you're seeing here. Ammonical silver ion here. Silver is depositing, and because that's been reduced, CHO group here. Hope you can see that there's another oxygen, extra oxygen there now. Okay. Three more slides. This uses up molecules in a chain structure to form. So more cyclic structure molecules would be coming out because you're dealing with the equilibrium. Yeah. If you use up chain structure, more of the ring ones would be consumed to make more of the chain structure one. The cyclic structure does not contain any aldehyde groups, so molecules in its form do not react with that. Finally, let's talk about solubility. Now, what do we say about glucose or glucose, fructose? So that's monosaccharides. Do they dissolve in water? Yes. But how many carbons are there? Okay. Isn't that a bit weird? Because any organic molecules which has 6 carbons in the chain should not dissolve into water, right? Why do you think that still dissolves? Yeah? You're right. Yeah, hydrogen and oxygen. What group are we specifically talking about here? Hydroxyl groups. Well done. So many hydroxyl groups are present in carbohydrates. Okay? So even in disaccharides, so sucrose, C12H22O11, there are 12 carbons even. But sucrose, that's normal sugar by the way. Does it dissolve in water? Yes. Why? Because of the polyhydroxyl group presence. Yeah? Having said that though, that's not always the case. If you have got long chain of carbohydrates, such as polysaccharides, such as starch, does it dissolve in water? No. If you ever cooked with starch, you have to suspend in cold water first and put in I don't know, stir fry or veggie or whatever. Chinese cuisine usually have that to make the sauce stickier. Yeah. So suspend in cold water because you don't want to cook and then make the polymerization happening in your bowl first. You want the polymerization to happen in the wok. So suspend it first. It doesn't dissolve. Suspend it, pour it into wok, and it will become nice and gooey. So yeah, anything that's longer than few monomer that would not dissolve in water, but shorter carbohydrates would do that. Okay, so that's an example about starch. And again, why does it still dissolve even if it's got 6 or 12 carbons within? Because of the OH groups. Yeah. Long carbons, they are too large to mix with water molecules and also have less OH groups compared to monosaccharides or disaccharides. Yeah. What else are the polysaccharides that you can see in the table? So we talked about cellulose. There we go. What does cellulose make?
Cell walls.
Cell walls, good. What has cell walls?
Skin.
Does it? Really?
Cells.
What cells? Plants, good.
Oh,
Because yeah, we only have membranes, right? Cell membranes. We don't have cell walls. Yeah?
Failing biology, it's okay.
No. We don't have cell walls. Plants do. Yeah? So plants' main fiber part is all made up of cellulose. I think it also has this formula, C6H10O10. O5, sorry. As I guess, the formula for the polymer. You know that wood doesn't dissolve into water, right? So it's starch. Yeah. So hopefully those examples would help you get to the conclusion. Any question? Alrighty.
Is glycogen.
Sorry?
Is glycogen a polysaccharide?
Which one?
Glycogen.
I'm not sure.
Just go
Does
with
it say that there?
It's multiple glucose.
If it's longer than disaccharides, is
Oh, yeah, I know, yeah, so.
it there?
Oh.
There we go. So it wouldn't dissolve into water then.
Which is probably good, because we're made of water. We wouldn't dissolve ourselves.
Thinker.
Don't want to dissolve every time we take shower. Alright, cool.